Chapter 7 Review. So in this chapter we talked about exponential functions and logarithm functions. And as I mentioned over and over in our lessons, logarithms is exactly the same as exponential functions. It's just presented to you in different format. So whenever it comes to logarithms, think about exponent. Logarithms, think about exponent. And one more thing, when you calculate, we have to follow the PEMDAS rules at all time. PEMDAS. So where does logarithm stand? Did you just hear me say logarithm and exponentials are exactly the same? And that's where logarithms is being calculated. It's being calculated as the same as exponent. So exponent falls behind parentheses. So whenever you calculate logarithms, make sure you have to follow the PEMDAS rules right after the parentheses. It has the same priority as the exponent. So now let's take a look at the questions here. For first one, it is trying to give you the information about growth and decay. How do I distinguish growth functions to a decay functions? Growth and decay, it all depends on your base. If your base is greater than 1, okay, so I emphasize the base. Whenever it comes to logarithm and exponential functions, we care about the base. The base is greater than 1. So what is base? Base is the number that being raised to a power. Base is the one that being raised to a power. If it's greater than 1, then it's going to be a growth function. If it's less than 1, it's going to be a decay function. Keep that in mind. And how about the small letter a? What does the small letter a stand for? Small letter a, you will see that it's given to you as the initial value, starting point, or y-intercept. Many terminologies to call it starting point, initial value, or y-intercept point. Number 1. A sound system purchased for $4,000 and it depreciates. The key word here is depreciate. So what does depreciate mean to you? It means that it will not retain its initial value. So as year goes on, the value will goes down. So keep that in mind. Depreciate means that your later year value is going to be less than the beginning. So if you start with $4,000 and depreciate at 10%, how are you going to calculate the values after 2 years, 7 years, 8 years, 10 years, 12 years? So we can use the formula given above. A of t, so that's your final value, equals, what's the initial? 4,000. You start with 4,000. That's what I keep trying to emphasize. 4,000 is your initial values. And then the rate, 1 minus 10%. So depreciate means that the value will go down. So it has to be less than 1. 1 minus a number. So obviously this number is going to be less than 1. 10% means that it's 0.1 in decimal format. So 1 minus 0.1, which is 0.9. So 0.9 is less than 1. Then raised to a power of t. And then the next thing is, we don't know when it falls below 2,000. So the best we can do is just plug it in numbers. When t equals 0, t equals 1, t equals 2, t equals 3, and so on. So obviously t equals 0 is where you start. So you should get 4,000 times 0.9 raised to the 0 power. Any number raised to 0 power is simply 1. So 4,000 times 1 is just 4,000. And that agrees with our initial value. So make sure you check your equation before you begin. And then the next process will be requiring you to plug in numbers. T equal 1, t equal 2, t equal 3, t equal 4, and so on. And you have noticed that when t equals 7, the value will be 1913, which is less than 2,000. And that is the year when will the value depreciate below $2,000. And then you can plot these points on the graph to your right. So our answer for number 1 is going to be 7 years. Number 2, so a bank pays you. So think about pays you. What does it mean, pays you? On a saving account of 4.5% if you deposit $10,000. So if you start with $10,000, as year goes on, you will get more than $10,000. So that means it's going to be an increase. It's going to be a growth function. So please keep that in mind. So letter A, we have A of t equals 10,000 times 1 plus 4.5% raised to the t power. And then letter B, simply replace your t with the years that it's asked. So it's t to the 5th power, t equals 5 and t equals 20. So check on your numbers there. Number 3, A culture containing 300 bacteria doubles. Keyword here is doubles. What does the word double mean to you? Doubles. Please keep in mind, double means that it's going to increase at 100%. Doubles. So basically means that if at the beginning you have 300, the next hour you will have 3 doubles is 6, so 600s. And then the next hour would be double of 6 would be 12, and so on. So our equation for letter A is going to be A of t equals 300 times 1 plus 100% raised to the t power. 300 is the initial population of the bacteria, 100% means doubles. So letter B, check on your answer, replace your t with 2 and 10. Number 4, tell whether each function shows growth or decay and justify. So I just mentioned this on the first at the previous page. When your base is greater than 1, then it's going to be a growth function. When your base is less than 1, then it's going to be a decay function. So just look for the base. Look for the base. The multiplier, the A initial value, is a tricky one. So letter A, I look at the base, 0.7. So ask yourself, is 0.7 greater than 1 or less than 1? Obviously, 0.7 is less than 1. It is going to be a decay function. Letter B, 4.7. 4.7. So I'm ignoring the 1/5. Have you noticed that? I am not looking at the 1/5. The 1 being raised to a power is 4.7. So that's our base. So look for the base. 4.7 is greater than 1. So it's going to be a growth function. Number 5, graph the relation on its inverse. So inverse, when it comes to table, you simply swap the two columns from x to y, y to x. And then you'll find the input domain and range is exactly being swapped as well because you just swapped the column. So number 6, use the algebra to write the inverse. Use your algebra to write the inverse. So make sure you follow the rule. How do you find the inverse functions? We practiced this several times already. So first thing, you want to swap x to y, y to x. So you have to do this simple change yourself from x to y, y to x. And then the next step is solving for y. So 2 steps for you to find your inverse functions. First, swap the input to output by changing y to x, x to y. Then you solve for y. So solve for y means that you want to put y all by itself. 1 times y on one side and then the rest on the other side. So use your algebraic scale and then check on your answers here. Number 7. So this type of question we just review and make sure you practice it. And the same basic concept I've been reminding you over and over when it comes to logarithm functions and exponential functions would be base, 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 base. So first thing, if a number equals a number in the exponential function case, see if you can change them into the same base. If a number equals a number in the exponential functions, you cannot change them into the same base. What do? Change into logarithm functions. So that's just like letter B. Third case, if a log equals a log, you have the same base. So the only way for these two numbers equal to each other would be they have the same argument. So which part is the argument? Which part is the base? Make sure you check your definitions. Base is the subscript. So base is a small number right next to the log. In the last case, log equals a number. You are not able to make the argument the same. Then you rewrite into the exponential functions. So those are the practice. So check on your answers, check your process, see if you have any questions. Question number 8, simplify. So do you remember that I asked you guys to practice the calculating logarithms with your mental calculations? So don't forget, when it comes to logarithms, you are thinking about the power, the exponent, the power, the exponent. So the base raised to what power equals the argument. base raised to what power equals the argument. And if you can simplify it down to a single logarithm form, that's your final answer. Or you can simplify it down to a single value, that's even better, and use your laws of log. What are they? Product properties, quotient properties, inverse properties, power properties, or the change of base. So these are some basic information for you to help you calculate. So make sure you practice. For example, letter A, 4 raised to what power equals 64. If you read it over and over, it'll help you understand better. 4 raised to what power? So we are looking for what power when it comes to logarithm functions. Number 9 and number 10. So we practiced these quite a few questions during our lessons, from exponential functions to logarithm functions, from logarithms back to exponential functions. And I mentioned in the inverse because it's being reflected across the y equal x line. Y equal x line. So whenever you see right, moving right in the original functions, then that means it's going to be moving up for the inverse functions. If you are moving up in the original functions, then it's going to mean that it's moving right for the inverse functions. If you're moving left for the original functions, then that means it's going to move down for the inverse functions. If you're moving down for the original functions, then that means it's going to move left for the inverse functions. It's kind of wordy, but it's a good way of checking your answers or come up with these solutions very fairly quickly. Otherwise, you will have to use your algebraic skills, just like you practiced on the page, the previous page, the lower portion, to calculate your algebraic expressions. So two methods, two ways for you to come up with the solutions. And either way, they should come up with the same result. So make sure you practice. And as I mentioned, when I do graphings, I don't really know how to graph the logarithm functions fairly well. So what do? I go back to the basic, which starts with the exponential functions. I get a few values from the x coordinate, and then I calculate the corresponding y output. So again, I start with the exponential functions, and then I calculate the y, and then I swap the x for y, y for the x for my logarithm functions. So that's the basic idea here. And make sure you practice and check on your answers.